There it is. Cool.
All right.
So, and we said like 15, 20 minutes, right? So
Yep.
I'll try to keep it within that time frame. And I definitely want to make sure that there's an opportunity to ask questions. So real quick, hi, everyone. I'm Vasanth online on my YouTube channel. I go by the name Fuseman for FusedVR. And so pretty much over the past, I'd say three or so months now, I've kind of been working on this open source project built off of Unity's render streaming SDKs and WebRTC, and integrating that with WebXR. And I'll talk a little bit more briefly about why that matters and why it's important. So broadly, I think it first helps to address like what is VR streaming. And for anyone who has tried Oculus Quest with AirLink, it's basically that concept where you have a VR headset. It is connected over a wireless, or could be wired, but traditionally in the case that we're looking at, it's wireless. And that's streaming, getting the data feed of images that are being rendered off of a high-end graphics card. So the two key components here is you have rendering happening on your desktop, and you have the input that's getting captured from the Quest and sent to the computer to be able to display the correct visuals that you then see within the headset. So really, the only difference then when we're talking about the concept of CloudXR is pretty much where is that server that is doing the rendering. So you still have the Quest, it's still sending input. The difference is it's not going to be on your local network. It's likely somewhere in the cloud, or what I'm particularly interested in is this concept of edge computing. So I briefly mentioned in the introductions, I work for a startup called Mobile EdgeX. So we work with all of these 5G networks around the world to enable you to get your access to data centers that are very closely connected network-wise to these 5G cell towers. So the advantage there is you have extremely low latency to the server. Your packets actually don't necessarily even need to go over the internet. And in a sense, it's basically as if you have a desktop that's running in the cloud. So you're going to have access to these data center grade GPUs that are significantly more powerful than whatever you could physically put on a VR headset. And instead of a desktop, you're typically working with virtual machines. But if you're not familiar with the concept of virtual machines, from a practical standpoint, it's basically the same thing as just having a desktop that sits in the cloud. And otherwise, it's pretty much the identical workflow of you're connecting over a network, there's a desktop that handles your rendering, and it sends that frames to your VR headset. And I often see a lot of people kind of get tripped up when they hear CloudXR because they don't know exactly what parts are happening and how the different devices play into together. So I'm hoping this kind of sets a baseline here for how this workflow works. And please stop me right now if you have any questions about how this works, because this is kind of the fundamental baseline of how all the WebXR integrations start to matter and play a role.
So this is similar to pixel streaming, like in Unreal?
Correct, yeah. And it's funny you mentioned that because I'm talking with a couple of companies along the lines exactly of how you could do the same stack with on Unreal as well. Any other questions?
I have a question for you.
Yeah.
Isn't this kind of new for Unity, whereas before you had to use the cable? This basically takes the place of you don't have to use the cable with Unity. It's streaming through the air. Am I correct or not?
Correct. So AirLink was basically where you had the cable originally. You can now instead use AirLink to connect over Wi-Fi. So that would be completely wireless. The same applies here. The idea is that this would be completely wireless. You're either on a cellular network or you're on local Wi-Fi, but conceptually correct. The whole point is that this would be wireless.
I have a question as far as Chromebooks, because I recently saw a presentation where a teacher was working with his students in California, and he was going through the air, and he was using Parsec. Unity just acquired Parsec.
Yep.
Would they be doing the same thing that you're doing then, or is that different?
So, so Unity, well, I can't talk directly about what Unity's play because they quite frankly, they're making a lot of plays in this space. The package that I'm leveraging from Unity has been around for a couple of years. It's called Unity Render Streaming, and that's all open source on GitHub. Similarly, a couple of years ago, they bought a company called Furious, which does 2D streaming, and it integrates with this GitHub project. And then, of course, recently, as you mentioned, they bought Parsec, which again is also more about the 2D streaming of games. So it kind of fits more along the category of cloud gaming. Conceptually, the networking stack is the same. The difference primarily comes down to the fact that you're viewing this in VR and you're sending a little bit more data, specifically one rendering per eye, as opposed to in the case of cloud gaming, where it's traditionally just the single flat screen that gets sent over the network.
But can you do both 2D and 3D both, or just is it 2D?
For this specific project we're talking about, it supports both 2D and
it does
and
support
3D.
both.
Yep.
It does.
Yep.
Thank you.
Yep. And well, I'll show a kind of a prototype-y demo at the end of this that hopefully can put everything contextually together as well. So this space has actually a lot of players here. The kind of primary, I would say, solution that's out there is NVIDIA Cloud XR, which has been around, I believe, for about 3 years now. And so they've been actively working in the space and I think really pushing the forefront of the idea that you would be streaming from VR. But as I mentioned, the networking stack is very similar to cloud gaming. So things like Google Stadia, for example, the difference is really the amount of data that you're sending. And then, of course, visualizing that and making sure you do the necessary steps to make that look right within VR. So those are kind of the leading companies, I would say, that are pushing this forward. But there are a lot of startups in the space. So HoloLight is an example of one that's working in the augmented reality field. And I think augmented reality is really interesting, more so in VR, because you actually also might consider sending the camera feed from your device up into the cloud, doing visual processing there as opposed to on device, and then packaging everything up together and then sending the video feedback. So there's, I think, a lot more complexity when it comes to the augmented reality space. Another player, QuarkXR, I actually have an interview going out with them, I believe, next week on our Mobile Edge X YouTube channel, which I think is very interesting in how they're tackling the solutions. Mowari is another interesting company that we've worked with in the past, again, looking at the augmented reality side of the spectrum. So as you can see, kind of broadly, lots of companies, and there are probably more that I probably haven't even seen yet, all working in this space and really kind of working with 5G companies to really push the forefront of what's possible and really make this an actual reality. But the current state of things is that it's primarily targeted at the enterprise. So it's really all right now today about the B2B cases. And you're not really seeing that much push from a consumer standpoint, which has to do with a lot of factors. But one of the big things that gets talked about here and there is that quite frankly, it's blocked from an accessibility standpoint when it comes to requirements that Oculus has when pushing out applications. So today, you are not allowed to push a cloud streaming solution to App Lab or the App Store. There are probably a number of reasons for this. Of course, I think the streaming space is a little bit early, and when I think about streaming, it's probably a 1 or 2 year roadmap to really kind of bringing that to consumer grade scale. But even at a I think a business enterprise play that Facebook is looking at. My guess is they probably want to make their own play as well. And again, pure speculation. I think they want to kind of limit what's happening in the space. And so from that reason, that if we're thinking about why all of these companies are targeting the enterprise, it's also the fact that it's blocked from a consumer standpoint when you're looking at the Quest. And that's a little unfortunate, right? It's just kind of the walled gardens that you might often see being talked about on Twitter. And I think that's really why I get excited about WebXR. So WebXR is a standard that is has been worked on for quite some time, and there's a fairly active community over on Discord that's really passionate about all of the work that's happening in allowing you to develop VR and AR applications natively through the web browser. It's built off of the OpenXR API standard, and it's available in browsers like the Oculus browser, as well as kind of traditional browsers like Chrome, that you could today start going to various different stores or sites on the web and being able to access that. There's a company called Construct Arcade actually that is trying to aggregate a lot of these experiences. And I think one, I don't believe they created it, but one of the apps that's on there is the SkiFit 365 that was recently published, which is a pretty compelling application, as well as several others that are being built in the ecosystem as well. But I think one of the challenges with WebXR is one, there's a tooling constraint. So actually, if I go back, you can use Unity to build WebXR applications, but the reality of it is it's not very performant. If you look at even traditional apps today, they typically tend to be gigabytes in size, and you don't really want to be downloading a full-fledged high AAA quality game into your web browser that's multi-gigabytes in size. You of course have rendering limits that you have to work with that are typically harder requirements than even just native applications. So if you're struggling to build a native Quest application, it's going to be even harder to build a WebXR application. So that's why I think when I think about the rendering stack and WebXR, it's really a natural fit. So CloudXR and remote rendering allow you to actually get over the hurdles of being limited by the constraints of the device, of being constraints of the browser, allow you to leverage existing game engines that you're probably already familiar with to build out compelling applications that are very high fidelity, high quality, stream that into a browser using the WebXR APIs to just literally just render the visuals, and you get the best of both worlds, being able to escape the walled gardens and having literally just a link that you could give someone to actually access your application, and at the same time making sure that it is very high quality and high fidelity. So that's the project that I've basically been putting together. It's available today as an open source project. You have the ability to, using the Unity SDK, create a game with Unity. You can target actually Windows or Linux, and I think we'll talk a little bit about the Linux in just a bit. But you can build out a Unity game, host that either on your desktop, or you can push that into the cloud. That gets streamed to the browser. You can access that at fusevr.com/rendering. And that's today what's basically been built out, is that the building blocks really to stream a VR application and have that work within WebXR. So step by step, it's really straightforward. I've been trying to design this in such a way that it's very fast to integrate. So if there's a Unity, or there's a GitHub repo, you import that into your project. There's a prefab, which you can see here in the screenshot, that you would just drag into your project. All of the building blocks that are necessary for that are integrated for you. And then you literally just kind of click play within Unity. You connect on the web browser, and then everything should work pretty seamlessly and straightforward for you. And it's not meant to be something that's terribly complicated to get started with. So I've said, I mentioned at the beginning, we've been kind of tinkering around with this for like a few months now. I would say it's kind of alpha quality at the moment. It's something that is still very experimental, and there are a lot of updates that are getting pushed on it. But if we're looking kind of into the future of what needs to happen, that there are quite a few different things. So from the server side of things and kind of deploying on the cloud, GPUs today can typically support 1 to 4 users per GPU. And so there's a slight cost problem from a consumer side of things. I think that NVIDIA is working actually very hard, and I talk constantly with NVIDIA. They're working very hard on tackling these types of problems. And it's really less so a rendering issue and more a video encoding issue. But I believe that these problems will get resolved in the future to help make these solutions a lot more scalable. And GPUs like the A40, I think, are an amazing step forward that NVIDIA is working on. And I think AMD as well is also making some really great steps in the space. 5G, I think, needs to become a little bit more accessible. Right now, we're seeing some infrastructure that's ready today to be used at a consumer level, but I think it needs to be scaled out a lot more. Right now, just the infrastructure is not fully there to make that compatible, but that's fastly being built out. And I would imagine probably within a 2-year time frame as well, you would start to see edge computing with 5G being a lot more ubiquitous, which I think is a lot faster than I would have initially ever said before I kind of worked at Mobile Edge X. From the project itself, I think there are optimizations that could be done still to make it more VR compliant. And that's kind of one of the reasons why I open sourced the project, was solely due to the fact that I think by having an open standard that people can start working towards and that's tangible, people can start building ideas to kind of build out more robust solutions faster. Something like late latching, where you're kind of tweaking the graphics right before you display it to the user, is something that's not currently implemented, but I think could go a long way to improving the visual quality that users would expect when viewing remotely rendered solutions. We touched on Linux briefly. I think that's absolutely critical to make that happen. Right now, the solution works today on Linux and Ubuntu, with a couple of caveats just due to driver constraints when it comes to certain features like real-time ray tracing. I think some of those solutions will likely get resolved as more of those APIs become standardized and kind of make their way to solutions, say like Vulkan or OpenGL, is my hope at least. But right now, a couple of those features are kind of locked behind Windows and DirectX. But I think if you're not using those features, Linux and Ubuntu is, it works. And it's quite frankly, I think the scalable option to really push out more and more content. And then finally, I think it's all about really the content at the end of the day. So having people that are looking to build optimized content that really can take advantage of these servers. The nice part about building on servers as opposed to client devices is that the hardware stack is typically fixed. And so you know exactly the specs that you're targeting, and you can, when you're testing, you know if it works on this server, it's going to work on other sets of servers. And so you can optimize for that, and you can really kind of max out the GPU based on number of users that are connecting, and how much graphical power that you have on that GPU, and you can constantly keep tweaking and adapting to optimize that content. So kind of as we wrap up, and then I want to open up this up for questions. As I mentioned, this is open source, so feel free to head over to our Discord server where you can chat with the rest of the community that's interested in some of these projects. You can also get access to those links at FusedVR.com. I'm giving a talk at AWE in November. I'm really excited about this talk. I think we have an amazing lineup, or a panel rather. So we have Greg Jones, who works at NVIDIA Cloud XR, myself, Louis, CEO from Awari. We have T-Mobile represented, and we have Sturfy, who's actually looking at visual positioning, so that augmented reality case where you're streaming the camera feed up to these servers as well to calculate real-time positional data. So should be a really awesome talk. Would love to see you there. And just a couple other links here. If you want to try this out today, if you're based in California, you can head over to FuseVR.com/rendering. Just type in the game ID for Oregon, and then you should be able to connect. I think I'm not sharing the right screen. Let's see if I do that. So connect here. I just put in Oregon, and oops, there we go. You can actually see I've been tinkering around with some like Ethereum integrations with the solution, which is a separate topic completely. But you can see here, this is streamed off of AWS on a NVIDIA Tesla T4. You can connect to it today. The server supports up to 4 players, I believe, is what I coded in. And I just coded this over the weekend, so it might have issues when you try it out. But I can connect in 2D mode here, and then you'd be able to, if you have a VR device that is in a browser that supports WebXR, you'd be able to enter virtual reality. Unfortunately, I don't have, well, I have my Quest, or not Quest, my Rift set up, but I don't have the drivers, Steam VR hooked up, but you could connect to this, say, on a Quest 2 and try it out as well. So yeah, hopefully, I think I covered everything. I probably went a little over, but I just kind of leave it up to questions at this point.
Yeah, terrific. Walking through of the whole system. Does anybody have any questions they'll ask?
Put one in the chat. Oh, go ahead.
Oh, you go ahead, Nicole.
I put one in the chat. You for that experience. What VR headsets support WebXR?
So Oculus Quest, of course, and then it's not so much. Well, I guess as long as the device itself supports, say, Steam VR, for example, if it's PC connected, then you should be able to connect through WebXR. So I mean that would be any HTC Vive headset, Oculus Rift, kind of your standard ones, or at least the main consumer ones.
And what clients have you tested this with so far?
You mean headsets?
Right.
Or yeah, I've tested this. I mean, as you can see here, I have the Rift. I've tested it with the Vive. I've tested it with the Quest and Quest 2.
Does it support audio?
So right now, I have one-way audio. The Unity render streaming solution itself supports bidirectional audio, which was included with CloudXR 3.0. It's just really a matter of me incorporating it, which is not terribly complicated. I just haven't gotten around to it, but it's on my list of things to do. Actually, I mean, if anyone is interested in contributing, or just like, if you're testing things, just head over to the GitHub repo, and then you can file a GitHub issue for this. This is where we're kind of tracking upcoming features and requests that need to be included. And yeah, you can see bidirectional audio support is one of those things.
So when a users connected into a single server, are they connecting into separate instances of the experience, or is it actually all connecting into the same application? So
in this case here, if anyone else connects, it'll be up to 4 players all on the same server. You could create replicas, and then at that point, it's kind of how you want to design your application and how everything connects and scales there. But this can support, I've set it up to support up to 4. And actually, I think when I ran this in the task manager here, and you see that encoder is kind of getting tapped out, this was with 3 users connected at that time. So I think 4 is reasonable. 5, 6, it starts to tax the GPU a little bit, at least in this case, using an NVIDIA Tesla T4.
And I said, that
What kind of
changes.
latency?
Oh, go on. Sorry.
I was going to say, what kind of latencies have you measured?
So in my setup, locally, I'm able to get 60 FPS. Off the cloud, what am I getting right now? I think like 30. I'm talking to a couple. So one thing I would be very interested in is if anyone has, well, depending on where you are, if you're in Tokyo, if you have a KDDI SIM, if you're in the US, if you have a Verizon cellular connection, let me know, because I'd love to test on AWS Wavelength, which is their 5G solution, what latencies you're actually able to get. I don't have Verizon access, and no one I talk to has Verizon access. But that would be the correct way of testing this out. Right now, I'm kind of testing off of Oregon in the cloud, which is not the most ideal scenario. When I've run tests in Germany, because MobileEdgeX has a lot of test servers located in Germany, we're able to get 60 plus FPS over on their networks as well.
Yeah, one thing I think is interesting about this approach is, especially if you actually can host multiple users within the same experience, it actually changes the way you think about multiplayer experiences. Normally, you spend a lot of time trying to sync objects and other items. This way, everything's automatically synced. It's just about, showing it to the users. So, which really can open things up quite a bit.
Exactly. And so I think the way I've set this up is that, so if anyone else connects in, you should just be able to see their avatar. And this sample, I've pushed that live on our GitHub repository, so anyone will be able to build this out, and can have, there you go, you see someone connected in, and it's one prefab, everyone's connecting to the same server, and the coding wise, it's very, very straightforward, that there's no other networking involved per se.
Did you answer, you said the question about latency, but then I think you were talking about frame rate. But
so
maybe I missed it when you said the like round trip. Do you have a round trip time or?
No, that's a good question. If we're talking in milliseconds, what I've seen, well, I personally have not measured things. I get reports of people in Germany measuring things, because that's where we have our 5G sites. What I've typically seen is somewhere in the orders of like 20 to 30, 40 milliseconds over on those test networks, which is fairly acceptable for VR. But as I mentioned before, I think the correct way for me to test in the US is actually off of the Verizon networks that are live today, which I haven't gotten around to doing.
Verizon Film and help test.
Sorry?
I'm on Verizon Film and help you test.
Yeah, no, that would be great. And yeah, well, I think we connected on LinkedIn, so let's definitely touch base, because I'd love to run those tests.
And is there any plans for like predictive, pose kind of things?
Good question. Short answer is I would love to. And so some of the potential projects that people have reached out to me is that's kind of one of the requirements that they're looking at. It's on my list, but I'm kind of actually looking for the right help to make that happen. So if that's something you're interested in, let me know. Happy to connect.
I was building an AR headset, and I've implemented my own kind of prediction, but it wasn't very effective. So I was like, like it's actually a pretty hard problem, because and in AR you notice it even more. And so it's very easy to overshoot, and it's impossible to fully predict, but it can help. So I think overall it can improve things, but if you're doing AR applications, you're still going to see wobble in the motion. So I had another question too. Is your goal for this to handle all the streaming through like FusedVR, or are you open sourcing the web stack?
So right now, I haven't thought about kind of the correct way to distribute the HTML side of things. Of course, as an HTML page, that's also open source. If you go click through Chrome, you'll find all the JavaScript that you want to do it. I just haven't packaged it in the correct manner. And then all the peering happens over WebRTC, which is also an open source project that was licensed by Unity. So the reality is everything really has been open source. The only thing that's kind of consumably open source is the SDK. But it's kind of one of those things that's on my list to do. But I think from a usability standpoint, it's kind of the easiest thing to do is run this through FusedVR.
Mm-hmm. Well, my thought is that if if it gets to be larger, your server costs could really go up, especially with AWS. So,
yeah. So I guess on that so I guess there's two things. So I guess the servers here are self-hosted by the developers. So the only server that I'm paying for is one, hosting my website, and then two, I have a very light WebRTC server that's containerized that I run on Google Cloud to help facilitate this. So actually, if you go to just point things out, if you go like this is just a WebRTC container that I run on Google Cloud. It's pretty lightweight, so that's really the only two things I'm paying for at the moment. One of the future things though is looking at the orchestration and kind of providing a platform that's a lot more consumer friendly to make it easier for developers to just kind of host an application, and then users would be able to connect. But then I think there's a lot more that I will have to think through in terms of, one, what that platform looks like, and then two, the cost structures associated with that. But today, anyone can use the site and host their own server and leverage what's there today. There's no hosting in that sense that's involved. Cool. Any other questions?
I just want to make sure if you have all the questions in the chat.
Oh, sorry, I have not been looking at the chat.
Yeah, no worries. I'm just going to make sure. There's like 2-3 questions.
Yeah, let me get you the Discord link. We'll go to this page. It's just like at the top. Is that in?
Would you be willing to share the presentation?
Yeah. I don't know what the best way to distribute that is though.
In the Discord channel, we also have the Discord channel. We can publish their slides or.
If you didn't want to export, share the Google Slides, you can always export a PDF of it or something like
that. Yeah, I don't mind doing that. I guess the question is, what's the right way to send it to everyone here? Or is it there like a meetup email thread or something?
Yeah, if you want, you can send it to us separate afterwards, and I can post it up to the group.
Okay. Yeah, let's do that.
All right.
I'm just looking through the chat. We talked about headsets. There was a question on A-Frame. So this is actually built off of A-Frame as the WebXR client. So that the integration happens to WebFrame, and then the way it works on the client side, it's really dumb, to be honest. It's just two planes that are sitting in front of your eyes, and then the image gets rendered onto there. There's a lot of optimizations that could be done on the client side to handle things a lot better in that capacity. Slides. I think we talked about the goals. GPU is the client. For the client GPU, I think it's mainly about performance, which I think we talked about. And yeah, I think that covers everything.
Well, thank you so much. This is really interesting, and I appreciate you sharing with the group.
Yeah, happy to. And yeah, looking forward to connecting with anyone who might be interested in contributing. And then, like I said, there seems to be some interest from clients as well. So would love to connect with anyone who would like to contribute and see what other magic we can make happen.
Thanks.